Greetings and salutations, everybody. This is Jacob. Okay, so how do we go about solving this problem? It's a bit easier than it looks, my friends. I know a lot of people get tripped up by algebra problems like this one, college students, for example. But here I'll show you how to solve problems like this one. They're quite fun to work out, actually, once you get the hang of it. So what does the problem state? It states that the horse and goat duo eat 20 pounds of hay in 2 hours. Let's state this in a more useful way, in a more mathematical way. We'll define eating 20 pounds of hay as doing one job. A is the work the goat is doing. B is the work the horse is doing. A plus B is their combined effort. Since it takes A plus B 2 hours to eat 20 pounds of hay, then that means they do half a job in 1 hour. Correct? Now, what else does the problem state? It says it takes the horse 3 more hours than the goat to do one job, namely to eat 20 pounds of hay. So we'll call the time it takes the goat to complete one job T in hours. So that means the horse completes the same job in T plus 3 hours. So now let's convert that work into 1 hour, just like we did with their combined effort. How much work do the goat and the horse do by themselves in 1 hour? The goat does 1 over T jobs in 1 hour, correct? And the horse does 1 over T plus 3 jobs in 1 hour. So now putting that all together, now we have a working equation, which is 1 over T plus 1 over T plus 3 equals 1/2, correct? So now it's simple algebra from here on out. We do the calculations and all the algebraic manipulations, and we end up with the quadratic equation t squared minus t minus 6 equals 0. The roots of that are t equals 1 plus or minus 5 over 2, which is t equals 3 or t equals a negative 2. And since t can't be a negative number, then t equals 3 hours. Since it takes the goat 3 hours to eat 20 pounds of hay, and it takes the horse t plus 3 6 hours to eat that same 20 pounds of hay. And that's your answer, my friends. 6 hours. Quite an intuitive answer, if you ask me. Oh yes. But wait, I'm not done yet. I have one more puzzle for you to solve. If this one was too easy for you, then I have something a little bit more involved in this video. So if you want to give the next puzzle a shot as well, and keep watching, it's as follows. Okay, so how the heck do we go about solving this problem? It seems confusing. Yes, it looks a bit confusing, but it's nothing to panic over. Just start from the beginning, just like I always urge you to do, my friends. So the problem states rows of 4 were formed with 3 leftovers, then rows of 5 with 2 leftovers, then rows of 6 with 5 leftover. So let's put that in mathematical terms. So first, let's make some definitions. Let's call M the number of rows of 5 that the band members formed. N is the number of rows of 4 that the band members formed. X is the number of rows of 6. L, the number of rows of 7. And Y is the number of band members that showed up that day. So moving on, we have this system of equations that describe the situation. And we're not going to try to solve this system in the conventional way, just like we always do with a system of equations. Let's turn our attention to the first expression, 5m plus 2 equals y. Since 5m is a multiple of 5, then that means the last digit of 5m is either 0 or 5, correct? That means the last digit of 5m plus 2 is either 2 or 7. So moving on to the next equation, 4n plus 3 equals y. So the last digit of 4n is, let's list out the multiples of 4. They're 4, 8, 12, 16, 20, 24, 28, 32, etc. So the last digit of 4n is 4, 8, 2, 6, 0. And then it repeats again in cycles of 5. So the last digit of 4n plus 3 is, we just add 3 to these cycles, which is 7, 1, 5, 9, 3. Correct? So the common last digit that these first two expressions have is 7. So the last digit of the number of people that showed up has to be 7, correct? So the last digit of the last expression has to be 7 as well. So let's just skip immediately to the last expression, 7l plus 1, so that we'll only have to check as few numbers as possible. You'll see what I mean in a little bit. So let's try to rewrite this expression so that it only spits out the multiples of 7l plus 1 that have 7 as their last digit. So the cycles of the multiples of 7 are, as you see here, cycles of 10 numbers. So the multiples of 7l plus 1 that only spit out numbers with 7 as their last digit are the 8th multiple, the 18th multiple, the 28th, etc. In other words, 7 times 10l plus 8 plus 1, which is 70l plus 57. So let's list out all the multiples of this expression that are under 700, which is 57, 127, 197, 267, 337, 407, 477, 547, 617, and 687. So we'll have to check 10 numbers one by one, starting with 57. So how do we check them, you ask? Well, you equate the first three expressions with each of these numbers, and you solve for m, n, and x. And if m, n, and x are all integer numbers, then the number we checked is a possible solution. So let's start with 57. So we have 5m plus 2 equals 57. We solve for m, and m equals 11. So now 4n plus 3 equals 57, which is n equals 13.5, which is not an integer. So 57 is eliminated. Moving on to 127, we have, well, m is always an integer when checking all these numbers, so we don't have to keep checking the first expression. Only the second and third expressions are the critical expressions. So 4n plus 3 equals 127, which is n equals 31, which is an integer. So now 6x plus 5 equals 127, which is x equals 20.33, not an integer. So 127 is eliminated. Moving on to 197 now. 4n plus 3 equals 197, which is n equals 98.5, not an integer. So 197 is eliminated. So now 4n plus 3 equals 267, which is n equals 66, which is an integer. So now 6x plus 5 is 267, which is x equals 43.66, which is not a whole number. 267 is eliminated. So now 4n plus 3 equals 337, which is n equals 83.5, which is not a whole number. Moving on, 4n plus 3 equals 407, which is 100. So now 6x plus 5 is 407, which is x equals 67. So 407 is our possible solution to our problem. Let's check if there are any other possible solutions. So moving on, 4n plus 3 equals 477, which is n equals 118.5, not an integer. Moving on, 4n plus 3 equals 547, which is n equals 136. And 6x plus 5 equals 547, which is x equals 90.33. So 547 is eliminated. So 4n plus 3 equals 617, which is n equals 153.5, not a whole number. So 4n plus 3 equals 687, which is n equals 171. And 6x plus 5 equals 687, which is x equals 113.66. So our only solution is 407. That's our answer, basically. That's the number of people that showed up that day, my friends. Oh yes, 407. So these were pretty interesting puzzles, wouldn't you agree? Let me know in the comments section if you liked them, if you found them hard, if you did them another way, etc. You know what, I think I'm going to adopt this format of videos as far as algebra puzzles are concerned. From now on, I'll be posting 2 algebra puzzles in one video. One easy puzzle and one harder one. As the saying goes, the best things come in pairs, and the same holds true for algebra puzzles. I'm going to do this so that people of various math skill levels can sink their teeth into the video without the video being either too challenging or too easy, you know. The puzzles from the other categories I'll continue as before, posting 1 puzzle per video, because those other categories are harder than algebra in general. As always, hit those buttons like there's no tomorrow. Send a puzzle suggestion my way, and I'll see you guys in the next video. Bye-bye.